how to write Lewis structures for covalent compounds. Before going into that, we should know what is chemical bonding, how chemical bond is formed, what is ionic bond, what is covalent bond, what is octet rule, all these things. Then only we can easily write the Lewis structure. See why a bond is formed between two atoms. You know, during 1916, two scientists, Kossel and Lewis, they presented a logical explanation for bonding, for the creation of bonding between two atoms. Their explanation was based on the inertness of inert gases or noble gases. I think you all might know what are noble gases and you can list out them, right? Yeah, helium, neon, argon, krypton, xenon, radon. All these gases are called noble gases, is it not? What is the speciality of noble gases? Yes, they will not react with other atoms. Why they are not reacting with the other atoms? Because these scientists, Kossel and Lewis, analyzed all these things and they said the inert gases have 8 electrons in their outermost shell. So, whichever be the atom, if they have 8 electrons in their outermost shell, they will become stable. Hence, they will not react with other atoms. That is the reason all these noble gases do not react with other atoms. So, what happens to what is the situation for other substances? They analyzed that and they also proposed that all the other atoms are trying to attain the noble electronic configuration, thereby attaining stability and becoming inert or stable. So, this is the reason for creation of a chemical bond between two atoms in a compound or in an element or whatever it is. So, a bond is formed. Where a bond is formed? A bond is formed between two atoms. Why a bond is formed? In order to attain stability. Why stability is needed? How stability is attained? By getting octet structure. So, what is octet structure? Octet comes from the number 8. So, Kossel and Lewis suggested that bond is created between atoms by sharing or losing or gaining of electrons. Thereby, the atoms attains octet structure. So, actually this was the basis for writing the Lewis dot structure. Now, before going into Lewis octet structure, Lewis dot structure, you know how a covalent bond is formed? Actually, there are many types of bonds, that is ionic bond, covalent bond, coordinate covalent bond, right. This Lewis dot structure can be written for covalent compounds. So, how a covalent bond is formed? A covalent bond is formed by the mutual sharing of electrons. Now, let us write Lewis structure for some of the molecules. Let us start from a simple molecule before writing the structure for any molecule. Let me tell you the rules. What are the rules for writing the Lewis dot structure? The rules are actually very simple. You need not worry for that. They are very simple. Lewis dot structure can be easily written. Let us take a simple example, H2O. You all know what is H2O is, water, no? What are the rules? First, let me sum up the rules. The first step is we have to write the skeletal structure of the molecule. Skeletal structures, we should write only the atoms without writing bond or without indicating electrons over it. It is step 1. What is step 2? In step 2, we have to calculate the number of valence electrons present in each atom. It should be added. We have to calculate the total number of electrons. I think you all know there is some difference between valency and valence electron. Valency is completely different from valence electrons. What are valence electrons? Valence electrons are those electrons present in the outermost shell of an atom, whereas valence is the combining capacity of an atom. What is combining capacity? Combining capacity is, in order to get that 8 electron structure or 8 electrons in its outermost shell, it may lose electron, or it may gain electron, or it may share electrons. So, how many electrons it gains, how many electrons it shares, or how many electron it loses, it gives you the valency. That is why it can be stated in a single sentence, combining capacity. So, we are not going for valency here. What we have to take in account only the valence electrons. So, what are valence electrons? Valence electrons are, yes, the number of electrons present in the outermost shell. We can calculate it for any atom. The first rule I have told you, the first rule. First rule is to write the skeletal structure of the molecule. Skeletal structure of the molecule. Second one is, yes, we have to calculate the total number of valence electrons. Total number of valence electrons. And the third one is, you have to put a bond between the atoms, bond or a line. You have to draw a line between the atoms, bond between the atoms. And the fourth point is, we have to give electrons, seeing that all the individual atoms present in the molecule has 8 electrons around its symbol. Okay, we have to check it, and in the fifth step, if there is any shortage of electrons, any shortage for 8, we have to give the electrons. Then in the final step, we will be arriving at the Lewis dot structure. Hope you all understand the points I have listed here. See, Lewis has told how a dot structure, electron dot structure, can be written for a single atom. For oxygen, see, let us take oxygen, carbon, hydrogen, for example, separately. If you put the valence electrons by a dot around its symbol, it is called dot structure. We know that for hydrogen, it has one valence electron. So, simply write the electron like this, or you can put like this also. This is the electron dot structure for hydrogen. See, for carbon, you know the atomic number for carbon is, yes, 6. Therefore, the valence electrons are 4. So, the 4 electrons can be written as dot around the symbol of carbon atom. So, this is the Lewis dot structure of carbon atom. And for oxygen, its atomic number is, yes, its atomic number is 8. Therefore, it has 6 valence electrons, which can be written as, only 4 electrons should be written separately. If you have excess electrons, in this case we have 2 electrons in excess, isn't it? Those 2 electrons must be paired with the already the electrons present already. So, 2 electrons. See, this is the electron dot structure of oxygen. Okay. Now, I have listed you the rules for writing the Lewis dot structure for covalent compounds. Now, let us apply the rules I have listed to a molecule, and let us arrive at the Lewis dot structure. Let us take a simple example. You all know water molecule H2O. H2O. For H2O, we are going to write the Lewis dot structure by following the rules mentioned just now. What is the first rule? We have to write the skeletal structure. Yes, we have to write the skeletal structure. See, without writing bonds, without writing indicating electrons, we have to just write the atoms, symbols of the atoms. So, when writing the skeletal structure, the electronegative atom should be mentioned first, should be written first. So, oxygen is more electronegative, and I am writing the symbol of oxygen in the center. There are two hydrogen atoms, and I am writing hydrogen here and one hydrogen here. So, the first step is over. Now, second step. What is the second step? We have to calculate the total number of valence electrons in the whole molecule. See, we have two atoms. One is oxygen and the other one is hydrogen. So, the total number of valence electrons is equal to, we have to add the valence electron of hydrogen and the valence electron of oxygen. How many hydrogen is present here? One hydrogen. So, let me first write like this, one hydrogen, right? Plus, how many oxygen atoms are there? I am sorry, two hydrogen, and there is only one oxygen. So, 1 into oxygen, right? Two water molecule contains two hydrogen atoms. So, 2 into hydrogen and one oxygen atom. So, 1 into oxygen. So, we are not going to multiply with the hydrogen. It means the number of valence electrons in hydrogen. Okay. What are the number of electrons in hydrogen? That is valence electrons. Yes, its atomic number is 1 and the number of valence electron is also 1. So, 2 into 1. Okay. Now, plus 1 into the number of valence electrons in oxygen. See, the atomic number of oxygen is 8. So, in the first shell we have 2 electrons, and in the valence shell we have 6 electrons. So, the number valence electrons are 6. So, 1 into 6, 2 into 1, 2, plus 1 into 6, 6. So, 2 plus 6, 8 electrons. So, the total number of valence electrons present in water molecule is 8. Step 2 is over. Now, going to the step 3. What is step 3? Again, we have to write this structure, skeletal structure here. So, I am writing the skeletal structure H, O, H, and you have to write a bond or a line in between the two atoms. So, here one line and here one line. Okay. Now, see, the total number of valence electrons we have is 8. We have written 2 bonds here. For one bond we need 2 electrons. For 2 bonds we need 4 electrons. So, out of the 8 electrons, how many electrons are used up? Yes, 4 electrons are used up. So, after giving 4 electrons for these bonds, how many electrons we will be having? 8 minus 4, that is 4. We will have only 4 electrons. Now, the next step, third step is over. Now, coming to the fourth step. What does the fourth step say? We should look into the octet structure. That is, we have to see whether the atoms present in the molecule has 8 electrons around it. See, first let us see for oxygen. See, oxygen has 2 bonds around it. So, for this bond 2 electrons, right? For this bond 2 electrons. So, totally 4 electrons. How many more electrons it need to get that octet structure? Yes, 4 electrons. See, we have 4 electrons. Let us give those electrons to oxygen atom. Okay. So, these 4 electrons must be indicated in electron pair. So, 2 electrons I have written like this, and the other 2 electrons we can write like this. So, now see, oxygen has 8 electrons around it. Coming to hydrogen, hydrogen should have 2 electrons. It has a bond here. Therefore, it satisfied the 2 electrons. So, this is over. So, we have 4 electrons. All the 4 electrons are used up for oxygen. This is the Lewis electron dot structure, and this structure can also be written as HO. See, you can see the 8 electrons around oxygen, and you can see the 2 electrons around hydrogen. This is the Lewis dot structure. Now, let us apply this rule to some other compound, some other example. See, you should not forget one thing. In writing the Lewis dot structure, the electrons shared should be written in between the atoms, whereas the electrons which are not involved in bonding should be written as electron pair over that atom or around that atom. We should not forget that. If the electrons are present in between the atoms, it is used up in bonding. If the electrons are above or below, it indicates that they are not involved in bonding. Let us go to another example. HNO3. Do you know what is HNO3? Yes, it is nitric acid. You know, there are some other acids or inorganic acids. Can you tell me some other inorganic acids? Yes, sulfuric acid, hydrochloric acid, nitric acid. These are the 3 major acids which we use in inorganic chemistry. Is it not? These are the 3 inorganic acids, main acids. This acid is HNO3, that is nitric acid. Now we are going to write this Lewis dot formula, dot structure for this nitric acid. See, what is the first rule as said in water molecule? The first step is to write the skeletal structure. That is, we should not write the bonds or electrons. Let us write. First, write nitrogen in the center. We have 3 oxygen atoms. Write the oxygen atoms like this. And we have 1 hydrogen atom, and this hydrogen atom can be written like this. What is the second step? Yes, we have to calculate the total number of valence electrons. So, the total number of valence electrons, is equal to, what are the atoms present here? 1 nitrogen, right? 1 nitrogen plus, and the next one is oxygen. How many oxygen atoms are present? 3 oxygen atoms. So, 3 into oxygen plus, there is a hydrogen atom, only 1 hydrogen atom. So, 1 into hydrogen, this is equal to, now we have to write the number of valence electrons in these atoms. Okay. See, nitrogen atomic number 7. So, 2 electrons in the inner shell, 5 electrons in the outermost shell, and that 5 electrons are valence electrons. I think you must all know these things. And oxygen, 8 electrons. So, 2, 6, this is the valence electron. And for hydrogen, it is 1. Now, for calculation of valence electron, 1 into nitrogen, how many electrons? 5, yes, 5 valence electron plus 3 into, for oxygen, yes, 6 electrons plus 1 into, for hydrogen, 1 electron. See, multiply and add all those numbers. 1 into 5, 5, plus 3 into 6, 18, plus 1 into 1, 1. By adding all these numbers, you will be getting 24. Am I right? Yes, we have 24 valence electrons in this molecule. What is the third step? Third step is we have to write a bond between all these atoms. So, I am writing the structure once again, nitrogen with the 3 oxygen around it and here one oxygen. Let us put a bond between the atoms. So, here one bond, here one bond, here one bond, here one bond. What is the fourth step we have to do? First we have to calculate how many electrons we have now. See, we have written how many bonds here? 4 single bonds. For one bond, 2 electrons. So, for 4 bonds, 8 electrons. See, out of the 24 electrons, 8 electrons are used up or given for these bonds. So, 24 minus 8, 16 electrons. We have 16 electrons with us. See, what is the fourth step? We have to check whether each atom has 8 electrons in terms of bond or electrons around it. If 8 electrons are missing, we have to give 8 additional electrons from these 16 electrons. So, let us move on from this oxygen. See, this oxygen only one bond here. One bond means 2 electrons. Am I right? 2 electrons. So, how many electrons needed? 6 electrons. Then only it can attain. There will be 8 electrons around this oxygen atom. 2 electrons are here. We need 6 more electrons. See, I am writing those 6 electrons like this. See, you should not write the electrons separately. You have to indicate the electrons in electron pair only. And for this, so 8 is over. Now, for this oxygen, there is a bond. Again, 2 electrons are there. In that bond, we need still 6 more electrons. So, those 6 electrons can be denoted like this. This is over. See, 2 plus 2 plus 2 plus 2, 8 electrons. Then coming to this oxygen, there are only 2 bonds. For 2 bonds, yes, 4 electrons. It still needs 4 electrons to get that octet 8 electron structure. So, we can give 2 electrons here and 2 electrons here. See, it has got 8 electron structure around its symbol. See, we had 16 electrons. So, let us check all the atoms present here contain 8 electrons around its symbol. See, this oxygen has 8 electrons. This oxygen has 8 electrons. This oxygen also has 8 electrons. But in nitrogen, there are only 3 bonds. So, 3 bonds means 6 electrons. So, it is in short of 2 electrons. These 2 electrons can be satisfied by the shift of these 2 electrons here. So, writing the final structure, nitrogen, 3 bonds here, oxygen. The pair of electrons can be written like this, and for oxygen, all the 3 pairs can be written like this, and for oxygen, since these electrons are written as a bond here, the remaining electron pair is written like this, and this hydrogen. So, see, for nitrogen, now 8 electrons in terms of bond is present here. This is the required Lewis structure for nitric acid.